Salvation International Preparatory School. Salvation International Preparatory School. A place to be, a school to go. We'll build you up from the cradle to university. Salvation International Preparatory School. Salvation International Preparatory School. A place to be, a school to go. We'll build you up from the cradle to university.
Good afternoon, everybody. Good afternoon, sir. How are you today? Thanks, sir. Today, for our chemistry class, we'll be looking at the gas law. Repeat after me. Gas law. Now, we'll see the importance of the gas law and what's the peculiarity of the gas laws. And for the gas laws, we'll be considering the following laws. The very first one is the Boyle's law. Repeat after me, the Boyle's law. The Boyle's law. We'll be considering the Charles law. The Charles law. We'll be considering the general gas law. The general gas law. We'll be considering the Dalton's law of partial pressure. The Dalton's law of partial pressure. We'll be considering the Gay-Lucas law. Everybody repeat after me. The Gay-Lucas law. Now, we'll be considering the ideal gas equation. Repeat after me. Ideal gas equation. And we'll be considering the Avogadro's number. What are we going to consider? The Avogadro's number. So let's begin. What's the first one we'll consider today? Boyle's law. Followed by? Charles law. Followed by? General gas law. Followed by? Dalton's law of partial pressure. Followed by? Gay-Lucas law. Followed by? Ideal gas equation. Followed by? Avogadro's number. So let's begin with the Boyle's law. In 1662, Robert Boyce stated the Boyle's law. Now, I said in 1662, Robert Boyce stated what? The Boyle's law. Now, the law is very simple. The law states that the volume of a given mass of gas is inversely proportional to the pressure. Can you repeat after me? Want to go? The volume of a given mass of gas is inversely proportional to the pressure. Can you take that again? Want to go? The volume of a given mass of gas is inversely proportional to the pressure. It means, therefore, that if volume is increasing, the pressure will be decreasing. And if the pressure is increasing, the volume will be what? Decreasing. Now let's equate it mathematically. What does V mean? Volume. Good. So it means volume. We'll remove this and introduce a constant equals to K over what? P. What is the K standing for? Constant. What is the K standing for? Constant. Now we'll cross multiply this to this. PV equals to what? K. Meaning P1 V1 equals to P2 V2. So class, anytime you see P1 V1 equals to P2 V2, what law is that? Boyle's law. What law is that? Boyle's law. Now there are a few things we need to answer this morning, or this afternoon rather. First, anytime we come across centimeter cube, dm cube, or liters, what am I talking about? Volume. What am I talking about? Volume. Good. Anytime we come across atm, millimeter mercury, and centimeter mercury, what are we talking about? Pressure. Good. Anytime we come across degrees Celsius or Kelvin, what are we talking about? Temperature. Very good. So let's take a question to that regard. The very first question says 375 centimeter cube. What unit will that? V1. Good. The V1, how many? 375 centimeter cube. Of a gas has a pressure of 770 millimeter mercury. What would I call that? P1, right? 770 millimeter mercury. Find its volume. What would I write here? P2. Good. If the pressure is reduced to 750 mmHg, what would that be? P2. So P2 becomes 750 mmHg. What law would I apply here? So what will be the law? P1 V1 equals to P2 V2. What is expected for me to do? Now, in this case, what am I looking for? P2. So what do I do? Divide both sides by P2 by P2. Therefore, V2 becomes, what do I have? P1 V1 over P2. Class, what is your P1? What was your P1 from your equation? 770 millimeter mercury. What is your V1? 375 centimeter cube over, what is your P2? 750 millimeter what? Mercury. Now notice something for us to know the unit. The millimeter mercury cancels the millimeter mercury. So class, multiply for me. 770 multiplied by 375. What do you got? So you divided by 750, what did you get? 385 centimeter. One more time. 385 centimeter cube. Why is it in centimeter cube? Because we are looking for volume. And what is V2? Volume. Now, one more time, state the boy's law.
As a parent, I have always asked, how can I prepare my children for the infrastructural development and socio-economic evolution of the next decade? With the ongoing speed of globalization, how can I position my children to perform excellently in a rapidly changing society? The answer is and has always been to give them a solid foundation. Academically, spiritually, and morally. Salvation International Preparatory Schools, with her team of highly qualified tutors, conducive environment for learning, state-of-the-art computer and science laboratories coupled with quality day and boarding facilities, is the place to be. For more information, contact 080-233-76135. SIPS remains the birthplace of leaders.
The boy's law states that the volume of a given mass of gas is inversely proportional to the pressure, provided that temperature remains constant. Very good. Now we'll take that as we've answered that. So the next one becomes what law? Charles law. What law? Charles law. Class, in 1787, a scientist by the name Jacques Charles stated the Charles law. Now, you might be asked to give the Boyle's law in a graphical representation. The Boyle's law in a graphical representation. You can just come this way. Make something of this magnitude in a graphical representation of this magnitude. You can represent P1. You notice something? V1. Because we said if the pressure is increasing, the volume is decreasing. I have P2. I have V2. Thereabout. I have P3. And I have what? V3. Thereabout. So let's continue. So we said, for the Charles law, a scientist by the name what? Jacques Charles. What year? 1787. Now, Jacques Charles made this very clear by saying the volume of a given mass of gas is directly proportional to the temperature in absolute Kelvin. What did I say? The volume of a given mass of gas is directly proportional to the temperature in absolute Kelvin, provided that pressure remains constant. Provided that pressure remains constant. So class, state that law. Want to go? The volume of a given mass of gas is directly proportional to the temperature in absolute Kelvin, provided that pressure remains constant. Now let's introduce the sign of proportionality. V is equals to what? KT. Divide both sides, so I'll be having V1 over T1 equals to V2 over T2. Class, what law would this be called? Charles law. So in Charles law, what are the derivatives? V1 over T1 equals to V2 over T2. I need you to understand something. If a question is given to you in degrees Celsius, am I going to be working with degrees Celsius? No. What will I add to it? 273 Kelvin. Very good. So I will add 273 what? Kelvin. To make it in what? In Kelvin. So let's take a question concerning the Charles law. At 17 degrees Celsius, what will I write here? T1 equals to what? 17. Am I leaving it this way? No. What would I add? What would I have now? 290 Kelvin. A sample of hydrogen gas occupies 125 centimeter cube. What will be here? V1. Equals to how many? 125 centimeter cube. He said, what will be the new volume? What will be here? V2. Equals to what? Not known. If the volume is at 100 degrees Celsius, what will be here? C2. C2 equals to how many? 100 degrees Celsius. Am I leaving it this way? No. What would I add? 373. So what would I have? 373. What formula am I using? Charles' law. And what's Charles' law? V1 over T1 equals to V2 over T2. Class, what are we looking for? V2. What are we looking for? V2. So we cross multiply by saying V1 T2 equals to V2 T1. Divide both sides by what? C1. By what? C1. So therefore, our V2 becomes, class, what's our V1? 125 centimeter cube. Multiplied by, what's our T2? 373. Very good. Divided by our T1. What's our T1? 290 Kelvin. Remember, Kelvin cancels Kelvin. Class, divide for me. 125 multiplied by 373 divided by 290. What do you have? 160.78. 160.78 centimeter cube. One more time. 160.78 centimeter cube. One more time. 160.78 centimeter cube. Good. Now we move straight to the next one, which is called. What's the next one called? General gas law. Now the general gas law. Now the general gas law is a combination of two laws. Who knows what are the two laws? The Boyle's law and the Charles law. The general gas law is a combination of two laws. What are the laws? The Boyle's law and the Charles law. Now, what does the Boyle's law say? The Boyle's law says P1 V1 is equal to what? P2 V2. So we call this one equation 1 or the Boyle's law. Now, what is the Charles law? V1 over T1 equals to V2 over T2. We call this one the Charles law. Now, what do? We combine equation 1, which is the Boyle's law, and equation 2, which is the what? The Charles law. Now, notice something. What is common between the Boyle's law and the Charles law? What do you notice is common? Volume. Right? What's it common? Volume. What is common? Volume. So call it, so we have P1 V1 over what? C1 equals to P2 V2 over what? C2. Good. Now let's add this to what we said concerning the general gas law. In the general gas law, there is something called STP. What did I say? STP. What does it mean? Standard temperature and pressure. One more time. What does it mean? Standard temperature and pressure. Now, because it is called standard temperature and pressure, there are stipulated values for it. The standard temperature will be what? 273 Kelvin. If it's the standard pressure, it is either 760 atm or 101,325 Newton per meter square or 1.01 times 10 to the power 5 Newton per meter square. Class, what is my standard temperature? 273 Kelvin. I can't hear you. What is my standard temperature? 273 Kelvin. What is my standard pressure? 760 atm or 101,325 Newton per meter square or 1.01 times 10 to the power 5 Newton per meter square.
Salvation International Preparatory School. Salvation International Preparatory School. A place